Assalamualaikum and greetings to all. Okay, let's proceed to the next example, which is example 3, item 3, where here we are given 1, 2, 3, 4 equations, and those are all the surfaces where your solid is bounded, and we are asked to find the volume by using the triple integrals. Okay, so here we have 1, 2, 3, 4 equations. Let's sketch this equation first, which is really a paraboloid. Okay. Right. So let's sketch this on 2D first. So here we have z plus x squared equals 4. You can rewrite this as z is equal to 4 minus x squared. So probably you can see it better. You can recognize this is an equation of a parabola that opens downwards. So let's say you sketch this on a 2D first on the xz plane. So what you have is a parabola that opens downwards where it intersect the z-axis at 4 and on the x-axis at -2 and 2. And if you look closely here, the equation doesn't have y in it, which means that it does not depend on y. So the shape will be the same no matter what y is. So let's say here we have a y-axis, x-axis, and z-axis. So let's sketch the parabola on a few values of y. So let's say that's y positive, and here we have y 0, and we have the same shape. All right, so let's sketch on xz plane. So here we have 4, 2, -2, so we have this parabola. And on this y positive plane, another parabola. So let's say here we have a 4, and here we have -2 and 2, so we have that. Okay, do notice that I do not sketch this further to below, because we have z0 here, so we don't sketch it below the xy plane, and because of y0 here, we don't sketch it further to the left. But we don't have any boundary yet on the right hand side, but that will be governed by this equation, which is a plane. Okay, all right, so let's sketch that plane. So here we have y plus z equals 4. So if we sketch this in 2D, which is going to be on the yz plane, it's going to be a straight line. Okay, so here we have a straight line where when y is 0, z is 4, and when z is 0, y is 4. And if you look at the equation here, it doesn't have x in it, meaning that it doesn't matter what x is, you have the same straight line. So let's sketch this on a few x equals constant plane. Okay, let's sketch for x positive and x negative. And we have when x is positive, it's just on the yz plane. Okay, so here we have a 4 and 4 on x0, we have this straight line. Okay, so and again, this is a 4 here and a 4 there, and then using the same slope for the next two lines. Okay, let's say here we have another straight line, and here we have another straight line, and then when you connect all the straight line, what you get is a plane. Okay, so this plane is governed by by this equation. Okay, and then we have x0 and y0. So x0 is the horizontal plane, and y0 is the vertical plane. Okay, so when you put them together, what you have is something like this. Okay, so when you put everything together, we have the parabolic cylinder, which intersect on the z-axis at 4, and on the x-axis at 2 and -2. So we have this. And here it doesn't go further because we have this plane y plus z equals 4. So this parabolic cylinder doesn't go to the right forever. Okay, so it's stopped at, let's say here, let's say that's a 4. And then we have the straight line, the plane, this plane here. Okay, and then we have the parabolic cylinder like so, and here we have at the back, and this is part of that plane. And of course, when you slice it, we have the vertical plane, the slanting plane there will be a bit curvy. Okay, so this is y plus z equals 4, and then we have the curvy bit. This is the curvy bit, which is really part of this parabolic cylinder there. Okay, right, and then we have z equals 0 at the bottom here, and y equals 0, the vertical plane here, right? Okay, I'm gonna erase that too many. Right, so let's erase this bit, that, oops. Okay, missing lots of it. All right, okay, all right, okay. Oh dear. Oh well. Okay, let me sketch that again. Okay, so we have this parabola here. Okay, right, and we have that parabola as well at the back. Right, so this is our solid G. Alright, and what we want is to find the volume. Okay, again, volume is dV integrate over solid G. If you recall from our notes, we have this. Okay, so volume is dV integrate over solid G. Alright, now we need to figure out where do we want to project our solid G onto. Well, obviously we cannot project our solid G onto the XY plane because our solid has more than one top surface. The top surface, one of the top surface is this slanting plane. This slanting plane, that's one top surface, and another one is this curvy bit. So we cannot project our solid G onto the XY plane due to the fact that it has more than one top surface. So a good choice would be to project our solid G onto the XZ plane, meaning that we need to integrate with respect to y first. Okay, let's do that. Okay, so we want to integrate this. Oops. We're gonna integrate with respect to y first. So here we have dy first, and then dA is going to be a region on the xz plane. So the region on the xz plane, x, y, z, so the region would be the region under the parabola but above the x-axis. Okay, now let's figure out the limits for y. So it's like having a torchlight on the right hand side here, and when you do that, the first surface that you reach would be this plane, but you have to rewrite the equation of the plane so that you have y in terms of z. So when you rewrite this, you have y is equal to 4 minus z. So that would be the upper limit for y, and the lower limit for y would be the left surface. So the left surface would be this, where y is equal to 0. Okay, y is equal to 0. Okay, now let's figure out our dA. Okay, so here we have from 0 to 4 minus z. Alright, so to get dA, you have to refer to this region, which is the projection of our solid onto the xz plane. So the good choice there would be to integrate with respect to z and then with respect to x. So looking at this region here, since x is the one you integrated last, so x should be from a constant to a constant. So by referring to this region, x is going to be from -2 to 2. And now to get the limits for z, you draw a straight line across your region parallel to the z-axis. So you can see that the upper limit for z is this parabola here, which is governed by this equation. So upper limit for z is 4 minus x squared. And the lower limit for z is the x-axis, where z is 0. Okay, now we can evaluate. Okay, again, integrate the inner integral first. So integrate 1 with respect to dy. So we get y. Replace y with upper limit 4 minus z. Lower limit 0. We still have dz dx. So from there we get 0 to 4 minus x squared. Replacing y with upper limit, we have 4 minus z minus the lower limit 0. So we have this. Okay, now the middle integration is with respect to z. So integrate 4, we get 4z. Integrate z, we get z squared over 2. Now replace z with upper and lower limits. Okay, replacing z with upper limit, we get 4 times 4 minus x squared. And here we have 1 over 2. 4 minus x squared, and you need to square that again. And lower limit is 0, so we have that. Okay, simplifying this, we get 16 minus 4x squared, and here we have a half. Expand 4 minus x squared, you get 16 minus 8x plus, 8x squared plus x to the power 4. And then we need to integrate with respect to x. Okay, let's simplify this. 16, and here we have minus 8, that would be 8. And the one with the square, we have this, which is -4. And we have plus 4, which is 0. Okay, and we have negative x to the power 4 over 2. Okay, so we have that. Let me erase this. Okay, so now we need to integrate this with respect to x. So that will give us 8x minus x to the power 5 over 10. Replacing x with upper and lower limit. So when x is 2, we have 16 minus 32 over 10. Minus the lower limit, so we have negative 16 plus 32 over 10. Okay, so simplify this. Okay, let me get my calculator. So we have 16 plus 16, which is 32. And then we have minus 64 over 10. Then we get 128 over 5. So that is the volume of our solid. Okay, so in this example, we have to project our solid onto the xz plane. Then this would be our region R on the xz plane. So the order of integration should be with respect to y first. Okay, thank you.